In this lesson, I'm going to introduce you to finding the inverse of a 2 by 2 matrix. The inverse of a matrix is similar to the reciprocal of a number. For example, the reciprocal of 6 is 1/6 and the reciprocal of 9 is 1/9. When you multiply the original number by its reciprocal, you get 1. So 6 times 1/6 is just 1, as is 9 multiplied by 1/9. But what about matrices? Let's call this matrix B. We use the notation B to the power of -1 to represent the inverse of matrix B. Something that's pretty cool is if we multiply these two matrices together, we end up with what's called an identity matrix. The identity matrix is a square matrix where all elements are 0 except for the number 1s that appear in the leading diagonal. Anytime you multiply a matrix by its inverse, you will always get an identity matrix. An identity matrix can be a 2 by 2, 3 by 3, 4 by 4, and so on. How do we actually calculate the inverse of a 2 by 2 matrix? We can use this rule right here. If we have the elements of matrix A, B, C, D, then the inverse can be calculated as 1 over AD minus BC, all multiplied by this matrix here. All we have to do to achieve this matrix is change the position of A and D, then change the signs of B and C. That's to say, if B was initially positive, then we would make it negative. Alternatively, if B was initially negative, we'd change it to a positive. Same goes for C. Time to work through an example. Consider the matrix 1, -2, 3, -4. We A, need to find the inverse of matrix C, and B, prove that the two matrices are inverses of one another. To do this, we just show that the product of the two matrices gives an identity matrix. Let's begin with A. We'll use this formula to help us. Firstly, I'm going to assign each of these elements with a letter from A to D, just like in our rule. Let's now substitute our information into the inverse formula. We have 1 divided by 1 times -4, as A is 1 and D is -4. Take away B times C, which is -2 times 3. Let's multiply all of that by a matrix following this orientation. D is -4, so I'll pop a -4 here. I'm going to put my A down here. A is just 1. Now for the B and C elements. We keep them in the same position, however we need to change the signs. B was initially -2, so we need to change that to a +2. C was initially +3, so we need to change that to a -3. Now to tidy up. Let's begin with our fraction, or scalar, out the front. We have 1 over 1 times -4 gives -4. Then we subtract 3 lots of -2, which gives -6. Let's just drop down our matrix. We'll keep simplifying this fraction now. We have our 1 over -4 take -6 is the same as -4 plus 6, which gives us +2. So we have a half times this matrix. -4, 2, -3, 1. Using our knowledge of scalar multiplication, let's distribute this half by multiplying it by each of the elements inside the matrix. A half times -4 is -4 on 2. A half times 2 is 2 on 2. A half times -3 is just -3 on 2. And finally, a half times 1 is just a half. Let's simplify this matrix where possible. -4 on 2 is -2. 2 on 2 is just 1. We'll just keep -3 on 2 as is, as we can't simplify it any further. The same with the half. It's already in simplest form. Part A complete. We've calculated the inverse of this matrix. Now on to part B. We need to prove that these two matrices are actually inverses of one another. The way to do that is to multiply them both together and make sure we end up with an identity matrix. Here we have matrix C and the inverse of matrix C. Let's go ahead and multiply these. If you need some extra support with multiplying matrices, you can check out my video on that topic. The first matrix is a 2 by 2, as is the second matrix. As these two middle numbers are the same, we know we can go ahead and multiply. We'll also end up with another 2 by 2 matrix. Recall that we only focus on rows from the first matrix and only columns in the second. To calculate our first element, we'll focus on row 1 and column 1. So we have 1 times -2 plus -2 times -3 on 2. To calculate this element, we focus on the first row and the second column. Our calculation is 1 times 1 plus -2 times 1/2. For this element in row 2, column 1, we focus on the second row and the first column, and end up with 3 times -2 plus -4 times -3 on 2. Finally, our element in the second row, second column, yields 3 times 1 plus -4 times 1/2. Let's simplify. 1 times -2 gives -2, plus -2 times -3 on 2 gives +3, as the two negatives give us a positive and the 2's cancel. For this element in the first row, second column, we have 1 times 1, which gives 1, plus -2 times 1/2, which gives us -1. For the element in the second row, first column, we have 3 times -2 gives -6, plus -4 times -3 on 2. Well, -4 times -3 gives +12, and we have that all over 2. That can cancel down to give us +6. For our final element, we have 3 ones are 3, plus -4 times 1/2 is -2. Let's do one more tidy up. -2 plus 3 gives us 1. In this element, we have 1 minus 1, which just gives us 0. Simplifying here gives us -6 plus 6, which equals 0. Finally, we have 3 plus -2, which is the same as 3 take away 2. This just equals 1. Since we've ended up with an identity matrix, we can in fact say that these two matrices are inverses of one another. That concludes our lesson on calculating the inverse of a 2 by 2 matrix. I'll see you in the next lesson. Bye!